Hello everyone and welcome back to the channel. In this video, we'll be learning how to plot the characteristics of an Nmos transistor using Ngspice. In our previous video, we covered the basics of Ngspice and also walked through the download process. If you haven't watched that yet, be sure to check it out first. So in today's video, we'll write a simple Nmos circuit using a netlist, simulate it in Ngspice, and finally plot IV characteristics, which basically shows how the current through the Nmos changes with different voltages. So let's start. So this is the circuit diagram we'll be referring. Here we are using enhancement type N-channel MOSFET. RG is the gate resistance. VGS is the voltage between gate and the source. RD is the drain resistance. VDS is the voltage between drain and source. And we are using V dummy here, which is 0 volts. Now why we are using this V dummy? We want to plot here current ID, drain current versus VDS for the various values of VGS. So in Ngspice, you cannot directly plot the current. So by making the use of voltage source V dummy, we'll find out how much is the drain current flowing through the terminal. So next we'll put up the nodes. So let's make the ground as node 0. Let's put here node 1. Let this be 2. Three here, 4 at the gate, 5 between this resistor and voltage source. So we have put up all the nodes. Next we'll move on to a Spice code. So in previous video I have shown you to download a zip file. So after extracting the file, we will get here Spice 64 folder. Click on this. Then you have to go to bin folder. Now whatever codes you are writing will be in the bin folder itself. And we have here console through which we will simulate the codes. So right click here and create one text document. So the first line will be always the title line. So let's write here Nmos characteristics. Next we'll write the netlist, writing all the components present in the circuit. So let's start writing the voltage source VGS and VDS. So VGS is present between node 5 and 0. 5, 0, and what is the value of VGS? 5 volts. Next, writing for VDS here, it is between node 1 and 0. Value of that is 2 volts. Next, V dummy, which is between 2 and 3, and its value is 0. Going for the resistances RG and RD. RG is between 4 and 5 and value is 10 kilo ohms. Next we have RD, which is between 1 and 2 and value is 5 kilo ohms. Last we are defining the MOSFET M1. So whenever we are defining MOSFET, it is drain, gate, source and substrate. So drain is connected to 3, gate is connected to 4, source and substrate are connected to node 0. And we have to give a model name here. As this is Nmos, I am giving the model name as Nfet. Next needs to define the model. So dot model, name of the model given here, that is Nfet, and type of the model is Nmos. Next here we will see the DC analysis. So dot DC VDS starting from 0 to 2 volts, and it will vary in the steps 0.01. Similarly, VGS will go from 0 to 5 in the steps of 1. So we will have 5 graphs for VGS. Next is the control. Under control, we will have run to run the code. To see the waveforms, we have plot. We want to plot current I across V dummy, ending the control with end C and ending the netlist end. So next we are saving this code. So go in the file, save as, give the file name nmos dot, extension can be .sp or .cir, and here select all files and say save. Next we have to go to the console here. So this is our file nmos.sp. We have to open this console, and here we just have to type the file name nmos.sp and say enter. So this is the characteristics, ID versus VDS for various values of VGS. So this is for 0, 1, 2, 3, 4, 5. So we have varied the VGS from 0 to 5 in the steps of 1. And that's it for today. Please like, subscribe and comment if you want more videos like this. Thanks for watching.